going to take a look at some basic differential equations, and we're going to look at two different instructions when you want to find the general solution and when we want to find a particular solution. So the general solution is going to encompass infinite amount of solutions, and here the instructions read, find the general solution for each first order differential equations. So what does first order mean? First order means that you will only be dealing with the first derivative. So I have this differential equation, which is dy over dx is equal to 3 over x squared. And so the way that you start a differential equation is that you get the dx to be with your x's and you get your dy to be with your y's, which in this case there is none, so you want your dy to be alone. So what I'm going to get here is I'm going to get dy is equal to 3 over x squared dx. And what I want to do here is I want to take the integral of both sides. Now remember, I can do something to the left as long as I do it to the right. So I'm going to take the integral of the left and the integral of the right. Now on the left hand side, I am taking this integral in terms of dy. Now what you want to remember is there's like a 1 that's assumed here. It's 1 times dy is equal to, and here I'm going to change this to 3x to the negative 2 dx. So on the left, I'm taking the antiderivative in terms of y, and on the right, I'm taking the antiderivative in terms of x. So on the left-hand side, the antiderivative of 1 in terms of y is going to be just y, because the derivative of y is 1. And on the right, I need to use the power rule. So I'm going to have 3x to the negative 2 plus 1 over negative 2 plus 1 plus c. So when I clean that up, I'm going to have 3x to the negative 1 over negative 1 plus c, which means that y will be a negative 3 over x plus c. And why do we call this the general solution? Because c can be any constant. So it's a general solution for this differential equation where again c could be any constant. Let's do one more like that. So again, I'm going to bring the dx over. I have 3x to the fourth minus 5x squared plus 10 dx. I will take the integral of both sides. So on the left, again, it's 1 dy, so I will just have y. And on the right, I will use the power rule. So I will add 1 to the top, divide by the new power, minus I1 to the top, divide by the new power, plus, and the antiderivative of a constant is the constant times x, plus c. And then I look to see if I can clean anything up, but I can't because 3/5 doesn't reduce and 5/3 doesn't reduce. So this is actually my final answer, my general solution. Okay, let's take a look now when the instructions changes to find a particular solution. So what it means when you want to find a particular solution is you're going to have a specific c. So you have a specific initial condition. So you start off the problem exactly the same. So I'm going to have dy is equal to the square root of dx, the square root of x times dx. You're going to take the integral of both sides. The integration of 1 times dy in terms of y is y. Here I'm going to rewrite it first as x to the 1/2 dx. Then I'm going to take the antiderivative. So I'm going to add 1, which will be 3/2, and then I'll divide by the new power, plus c. Remember that when you do integration, the integral and the dx go away together. Right? So once you take the integral, they both go away. Now dividing by 3/2 is the same thing as multiplying by 2/3 plus c. But now what the difference is that we're going to actually find c. So we know that when x is 0, y is 5. So I have 5 is equal to 2/3 times 0 to 3/2 plus c. But 0 to any power is 0, so this is 0 plus c, which means that c is 5. So my final answer is y is equal to 2/3 x to the 3/2 plus 5. And here's my particular solution. So this little guy right here would have been my general solution, but because I know now what c is, this is my particular solution. Okay, Let's do one more. So I'm going to bring the dx over. So I have dy is equal to 3 over x minus 5e to the x plus 10x dx. I'm going to take the integral of both sides. So I have 3 over x minus 5e to the x plus 10x dx. On the left, that will give me a y. On the right, I will have 3 ln of the absolute value of x minus 5 antiderivative of e to the x is e to the x plus 10x, add 1 to the top and divide by the new power plus c. So this cleans up just a little bit. I have 3 ln of the absolute value of x minus 5e to the x plus 5x squared plus c. And I have up here that when x is 1, y is negative 3. So I have negative 3 is equal to 3 ln of the absolute value of 1 minus 5 e to the 1 plus 5 times 1 squared plus c. So this is going to be negative 3. The ln of 1 is 0, so this will be 0 minus 5e plus 5 plus c. I'm going to isolate c, so I'll add a 5e and I'll subtract by 5. So that will give me a positive 5e minus 8. And I'm not going to find a decimal value for that. I'm going to leave it as e, and I'm going to plug that into my y. So I'm going to have 3 ln of the absolute value of x minus 5e to the x plus 5x squared plus 5e minus 8. And here's my final answer. Here's my particular solution.